Hello, my name is Mattori. This is my second milestone video for BlueStamp engineering for the Raspberry Cloud / OwnCloud project. I apologize in advance for the poor mic quality. My computers currently have commissions. I'm actually using a family computer right now, and I'm using my phone as a microphone. So I'm going to have to ask you to bear with it. Hopefully it won't be too bad. So this is my project. This is what I've been spending most of the past couple of weeks working on. Considering code is maybe 80 to 90% of the project, it's time well spent. So I actually have a bit more code than this. I've just been taking all this code and kind of just reamping it, making it a little less complex. So that's what I've been spending the past couple of days on. So I'm going to give you a really quick run through of my code. And then I'll just give you a couple examples of some of the really cool stuff that I found along the way. So what's basically going to do on startup is it's going to check to see if there's a program folder for this. If not, then it'll say, oh, this is new. This is the first time they've run this program. So it's going to ask you for username input, username, password, and the root directory that you want synchronized. If not, it'll still ask for login info. And what it will do is it will make a object. One of this. File transfer connection object. So what this connection represents is a connection to the server / to the file system. It does both. So after the handshake with login information, it has a couple of methods as send file. So basically just read directly the bytes and send it directly to the server through sockets. Also the receive file version and just a couple wrappers rather. To just make sure the protocol's all good. So it'll say request download this file, just to make sure it's all organized and make sure the server and client both know what's going on. And then I have the index here. So the point of this is basically my program is going to be watching for changes in a given directory cursively. And while that's good and all, if you start up the program, then turn it off, and then do stuff, and then turn it back on, it needs to be able to recognize that you did things, that you changed stuff, because I can't assume that you're gonna have this running 24/7. So the way it compensates for this is it's going to do an index of the file. So it's going to get some basic information, last modified data, size, if it's a binary file versus a text file, because it makes a difference on Windows, and then identification number, which is inode on Linux or OS X, and then file index if you're on Windows. So I'll show you how that's done in a second, but basically the reason for that is that if you have a file and you just update it, then yeah, it's at the same path, it'll recognize that. If you move it but you don't change it, then it'll still recognize that because of the last modified metadata. But if you move it and you change change some of the content, there's no way that it can actually recognize that that it's really the same file, except for the inode / file index number. So what these numbers do is it basically identifies the file uniquely on the file system. So if you move it around, no matter what you do to it, unless you delete it and then restore it, I can't guarantee that the number will be the same, but otherwise it will be constant, which is very, very helpful. This is a method that basically compares two versions of the index. And then just says, okay, oh, it was deleted, oh, it was moved, oh, it was updated, what have you. So we have methods here that will do a really simple configuration write or read from the configuration, which will write or read the index. That way, if you close the program, it'll still be able to read it. Then finally, we have the queue handler, which allows multi-threading. It's pretty recent, so that's why there's a bunch of passes here, not actual code. But what it's going to basically do is there's going to be a queue for sending files and receiving files. That way it can send and receive files at the same time as it watches for changes. So the way this is going to work is it's going to have a synchronized queue, and so this queue handler is going to just look at the queue, see if it's empty. If it's not empty, then it's going to look at all the entries in there, and the entries will have a key called mode, and the mode will have a value. If it's download, then it wants to download from the server, download a version from the server. Otherwise, it will have information on what changed in the file system, what specifically. So like if it was deleted, if it's a new file, if it's updated, if it was deleted and then there's a new file there, because the board can recognize, and a bunch of stuff. I also have the server here. I haven't spent as much time on it because the client requires a significant amount of time to spend on, and while the server I'm sure I'll have to spend a bunch of time on, it's definitely going to be easier. I hope it's going to be easier. It was really difficult to do the client in some parts. Specifically, this part. So this is using the Windows API in Python using PyWin32. It's very, very, very helpful. So basically, it allows you to use the Windows equivalent of inodes, and of course, inodes are very important, as I've mentioned. So what this is going to do is it basically reads this file, which I have here, file.txt, and it has a very specific index number. The file index number, high and low for accuracy, I assume. And then it also has the last modified time and size. This is stuff that's built into Python, but this specific index, the file index, the file index numbers, they're a part of the Windows API. It's not something that's built into Python. The equivalent in Python is the inode number, but that's 0 on Windows because it doesn't support that. So really quickly, this basically just creates a handle from the path. This is just specifying, I just want to read the file, I'm not going to be doing any writing, and it just gets information from that. This is a little more, this is just everything that comes from it. So it has stuff like last access time, when it was created, a bunch of other information that's useful, but not as useful to me. And then finally, we have the watchdog, which is going to be checking the directory for changes. It uses a multitude of things. It uses not just Windows API, it also uses polling, I believe, which is pretty standard, but it uses Windows API, it uses iNotify, it uses a bunch of pretty useful things that all come together very nicely. Caps lock. So we have the file here. If I delete it, it will show up, oh, you deleted this file. I undo that, which basically recreates it. It says, oh, you created the file, and you modified it, I guess. Modified from the base of the file. I guess because it has contents. Hello there. If I rename it to, say, QWERTY, let me spell QWERTY, it'll say that you moved it, which is basically the same as renaming it for all intents and purposes. It changed path, basically. And then you modified the file also because you changed the title, or the name of it. And if I undo that, then it'll say that as well. So this is very useful. I mean, clearly it's very, very useful to my program. So I've still got a bit of a ways to go. For the most part, thankfully, the majority of the work is done. A lot of the research is done. The research was probably the hardest part. There's a lot of stuff that seems really, really useful. Like rsync seems really useful, but it's just not going to be easy to implement, and it's not going to it's probably not going to fit in the program perfectly. So yeah. So thank you for watching. Hope this was interesting.